Hello dear students, in this video we see the eigenvalues of matrix A. Eigenvalue is used to determine the similarity between different signals or similarity between two signals. So let us see what exactly the eigenvalue of matrix A. Consider the equation Ax is equal to y where A is n by n matrix, x is n by 1 matrix and y is also n by 1 matrix. View this equation as transformation of vectors x to vector y by matrix operator A. So if we want to transform the sequence from x to y, we have to apply the matrix operator A on it. Here we have to determine whether there exists a vector x such that the matrix operator A transform it into a vector lambda x, that is y. That is vector having the same direction in state space. So Ax is equal to lambda x. Therefore, if we take lambda x at left side and taking x as common, we get lambda I minus A into x is equal to 0, where I is the identity matrix. Because why this I is there? Because this A, X and Y, these three terms are the matrices, not the values, not the single values. These are matrices. So if we take X as common, lambda I is remaining, where I is the identity matrix. So lambda I minus A is equal to 0. This equation have a trivial solution if and only if mod of lambda I minus A into x is equal to 0. So from this equation we have to calculate the values of lambda. This can be written in the expanded form as q lambda is equal to lambda raised to n plus a1 lambda raised to n minus 1 plus a2 lambda raised to n minus 2 up to an, that is equal to 0. The value of lambda for which equation 1 is satisfied are called as eigenvalues of matrix A. It is very important. The value of lambda for which the equation 1, that is lambda I minus A into x is equal to 0. So we have to determine various values of lambda. So for which values of lambda the equation is satisfied, or for which values of lambda we get 0 values, that is the eigenvalues of matrix A. And matrix 2 is called the characteristics equation corresponding to matrix A. Eigenvalues of state model and its poles of the system transfer function are the same. The state model is stable if all its eigenvalues have negative real parts. This is also important, that a state model is stable if all its eigenvalues have negative real part. Now if for lambda is equal to lambda I, if we put the value of lambda I instead of lambda, we get lambda I minus A into x is equal to 0. Let x is equal to mi be the solution of this equation. The solution mi is called the eigenvector of A associated with eigenvalue lambda I. So if we know various values of lambda, that is eigenvalues, and we get the solution mi, then these mi solutions are called as eigenvector of matrix A. This is very important, that solution of lambda I is known as eigenvector. So this is about eigenvalues and eigenvector. Thanks for listening.